Hello students, we will continue this video series on Chapter 5, Normal Distribution. We will go into Part 5C, which is the typical question we're working on. We're looking for the probability that a randomly selected individual will have an IQ greater than 90. So let's continue here. So first step is to calculate a Z value. X is 90, the average is 100, and the standard deviation is 15. Gives us a Z value of negative 0.67. Oops, that's not a 7. There we go, negative 0.67. Second step is to find an area that is associated with that Z value of 0.67. So what we need from there is the normal distribution table reference. Oops. Included in your course package. This is on page 126. So it's negative 0.67. When you're finding an area, always view a Z value as positive. So where Z value 0.67, there's 0.6, and in this column here we're going to have 0.07. So the Z value is 2486. So let's write that in there. Area 0.2486. And what we're going to do before we get to step 3 is to draw out the normal distribution. The middle is where the average is. The average is 100. Has a standard deviation of 15. We're just going to make that note up there. And we're looking for the probability that a randomly selected individual has an IQ greater than 90. 90 is on this side. So there's X equals 90. And it says greater than 90, so we want all of this area, plus we want all of this area on the right side of the normal distribution. So we're looking for all of this. The area from the middle outwards, middle to this value, is 2486, and this area here, all that area on the right side, is 0.5. So step 3 becomes easier if we draw this out. We know that the answer is going to be 0.5 plus 0.2486. So our final answer is 7486. So just under 75% chance of randomly selecting an individual from the general population that will have an IQ greater than 90. So let's go on to part D. Let's erase this, and part D asks us to determine the probability that it's less than 112. So this is D, basically less than 112. So randomly selecting an individual in the general population that has an IQ of less than 112. So X value is 112. We're working on the same general question of an IQ average 115, standard deviation of IQ average of 100, standard deviation of 15. So in this case, our Z value is going to be 0.80. Step 2 is to find an area that's associated with that area where that Z value 0.8. So we go on to the normal distribution chart. We have 0.8 is right there, 0.80, 2881, 0.2881. Now we're going to draw out this normal distribution. in order for us to get a really good idea of how to solve for step 3. So the average 100, standard deviation 15, and greater than 112 is on the right side. There's 112. Less than 112. So the word in the question is less than 112, so we want all of this area, which is less than 112, plus all of this area to the left side of the normal distribution. So we want all of this. Well, we know that this part in here is 0.28881. Remember, the area always goes from the middle out to that specific x value. This side over here is 0.5. So step 3 gives us our answer. It's going to be 0.5 plus 0.2881, so 0.7881. So just under 79% probability of randomly selecting an individual who has an IQ of less than 112. Okay, so in these last examples we've done 4 examples. Sometimes we add 0.5, sometimes we subtract 0.5. It depends on what side we start on, the left side or the right side of the distribution, and depends if we are going more than or less than. So the best way to get that final answer is to do a quick little diagram right in here, draw this out, and it'll help you get that final answer. Okay, let's go on to E. From our PowerPoint, E is a little different. E basically says between 89 and 114. Okay, I'm going to draw this out first because this is a different one, different type of process. So basically, between 89 and 114. So what's the probability of randomly selecting an individual who has an IQ between 89 and 114? So let's draw this out. We're going to draw it out a little bigger. Once again, average is right in the middle. Has a standard deviation of 15, just so we don't forget what that number is. Between 89 and 114. So 89 is on the left side, and there's an 89 there's an x value 114 on the right side. So we have 2 x values. So we're going to have 2 z values. Those 2 z values are each going to give us an area. So let's calculate a z value for 114. That works out to be 0.93. So a z for 89, remember we have to calculate a z for each x value we have. This is going to be negative 0.73. We will never add or subtract z values together, but what we can do, given this is step 1, is finding a z value. Step 2 is finding an area for those 2 z values. So once again, we go to that chart, 0.93, 0.73. So there's 0.9, 3238, and 0.73 is 2673. So let's write those areas in here. So the area for 0.93 is 3238, and the area for 0.73 is 2673. Our final answer, our step 3 answer, is going to be taking these numbers here and basically add those areas together. So we will get something like 0.5911. It's basically taking that area and adding them together. We know we're going to add them together because if we go back to that chart, we want this area and we want this area. This area on the left side is 2673. That's over here. The area on the right side is 0.3238. So we want that combined area, so that's why we're adding them together. Okay, that's part E. Let's erase this and do F. F states we want the probability of randomly selecting an individual whose IQ is between 122 and 132. So this is part F, 122 and 132. We're going to draw this out, so let's just write this in here, between 122 and 132. Let's draw this out. The average is right there, 100. Standard deviation we'll put up there. Here is 122. And here is, I'm just going to make this a little further down, 132. And we want the area, or the probability, between those two values. So this is going to take a little extra work. There's two x values, so basically we have two z values. 132 minus 100 divided by 15 gives us a z value of 2.13. And a z value, this is step 1, z value for 122 gives us a z value 1.47. We go to the normal distribution chart we have. We find 2.13, there's 2.13, and 1.47 is right there. So we indicate those two numbers. So 2.13, the area, step 2, is 4834, and for z value 1.47 it is 4292. So let's just chart this out here. So this number here, 4834, that is from here all the way out there. There is 0.4834. And this number here, 4292, is from here all the way there, 0.4292. So the blue area, 4834, includes that green area but does not include that red area. So the final answer for the step 3 answer, or the step 3 process, is to get our answer. Basically it's going to be 4834 minus 0.4292, which gives us value of 0.0542. So just over 5% chance of randomly selecting an individual who will have an IQ between 122 and 132. So part F, the difference between E and F is that F, the two x values were on the same side. So if they are on the same side, we're going to subtract larger minus smaller. If they are on opposite sides, as was 5E, we would add them together. So we will go on to part G of this question in the next video.